SR concepts. I am Ravi Verma. In this video, I am going to start NCERT solutions of chapter number 2, that is matter around us pure, from your NCERT textbook of science for class 9th. This is the part 1 of NCERT solution, in which we will discuss the in-text questions which are given within the text of your chapter in your NCERT book. The NCERT exercises which are given at the end of the chapter will be covered in the second part of this video. So let us start the first in-text question. The first question is, what is meant by a substance? Dear students, you know that matter can exist in two different forms. One is the pure form and the other is impure, that is mixture. So pure matter is called substance. In the language of science, a pure substance consists of single type of particles. For example, if we talk about water, then water will contain, if we talk about pure water, then water will contain only same type of molecules, same type of or one type of particles. In the same way, if we talk about iron, then pure iron will contain only one type of atoms, that is iron atoms. So we can say that iron and water both are pure substances. So this is the full definition of a substance or a pure matter. So the terms substance or the pure matter are synonymous. Alright, next let's move on to the next question. List the points of differences between homogeneous mixture and heterogeneous mixture. Dear students, you know, when two things mix completely, when two substances mix completely in such a way that the small particles of the components cannot be seen with the naked eyes, then it becomes a homogeneous mixture. A homogeneous mixture is also called a solution, right? So what is the difference between a homogeneous mixture and a heterogeneous mixture? Let's understand by the help of this table. What is written? It has a uniform composition and every part of the mixture has the same properties. So if we talk about a homogeneous mixture, then it will have a uniform composition, means its composition will be same throughout the mixture, and every part of the mixture will have almost the same properties. Actually the same properties. Okay, so the example of homogeneous mixture is like if you mix salt in water. If you mix salt plus water, then it will be a homogeneous mixture. So you know that everywhere the composition will be same and everywhere the property, the taste will be same, the composition will be same. But if we talk about heterogeneous mixture, they do not have a uniform composition and property, means their composition varies at different places, right? So if we talk about, suppose we have taken a test tube, we have added some sand in it, we have added some sand in water, then you know that most of the sand will settle down at the bottom and the sand particles will be lesser at the upper side. Okay, so here we can see that at the bottom the amount of sand is more, but at the top the amount of sand is least, right? Or minimum. So here we can see that the composition of this mixture, that is water plus sand, is not uniform. So we can say that heterogeneous mixtures do not have a uniform composition, and because of this their properties are also not uniform. Okay, now there are no visible boundaries of separation between the components. This means that when there is a homogeneous mixture, you cannot see clearly where is one component and where is another, right? So you cannot see the two components separately. For example, when you mix salt in water, then you cannot tell by looking at the mixture where is salt and where is water. In the same way, we talk about the heterogeneous mixture, then there are distinct boundaries of separation between the components, means you can clearly see where is one and where is another component. For example, if we take a heterogeneous mixture of sand in water, then there is sand one component and water is another component, right? So you can clearly see where is sand and where is water in such a mixture. So in heterogeneous mixture there is a clear-cut boundary of separation, means you can find out where are the components. Okay, you can see clearly where are the components. Okay, now examples of homogeneous mixtures are tap water, air, ice cream, sugar syrup, ink, steel, bronze, salt solution. In the same way, if we talk about heterogeneous mixture, then soil is a mixture, right? A mixture of iodine and water plus common salt you can take, and mixture of sugar and water, mixture of oil in water, mixture of sulfur and iron fillings, and mixture of milk and cereals, right? So these are different examples of heterogeneous mixtures. Okay, now let's move on to the next question, the question number 3. This is a very important question, right? And it can be asked, it may be asked in 5 marks also. So what is written? How are sol, solution and suspension different from each other? Dear students, you have studied that sol is a type of colloid, okay, and you have also discussed about solution and suspension, right? So we are going to differentiate them from each other on the basis of some attributes. These attributes are type of mixture, size of particles, Tyndall effect, right? And there are further appearance, visibility of particles, diffusion, stability, settling of particles, and further the examples. So let's talk about, first of all, the type of mixture. You know, sol is a colloid and colloid is a heterogeneous mixture. Solution is a homogeneous mixture and suspension again is a heterogeneous mixture. So out of these three, only solution is a homogeneous mixture. Now if we talk about size of particles, you know that in colloids the size of particle is between 1 nanometer to 100 nanometer, 1 nanometer and 100 nanometer. Okay, if we talk about solution, then the size of particle is lesser than 1 nanometer, and if we talk about suspension, then it is more than 100 nanometer. So actually particle size is very important in determining the properties of colloid, solution and suspension. Look, the properties, the attributes which we are going to study further in this table, all of them depend on the size of the particle. For example, if we talk about Tyndall effect, then Tyndall effect is exhibited by sol, that is a colloid. The reason is that the particles are big enough, that is 1 nanometer to 100 nanometer, so they will show the Tyndall effect. What is Tyndall effect? It is the scattering of light and the path of light being visible when the light is passing through the sol. Okay, if we talk about solution, then solutions, the particle size is less than 1 nanometer, so they do not scatter the beam of light, and this is why the Tyndall effect is not visible. Now if we talk about suspension, then they exhibit the Tyndall effect as long as the suspension is not settled down or broken. If you leave the suspension undisturbed for some time, then you will see that the suspended particles will settle down at the bottom. The suspended particles will settle down at the bottom, and then you can say that the suspension has broken. And when the suspension has broken, then it does not exhibit the Tyndall effect. Okay, if we talk about appearance, then usually the sol has glassy and clear appearance, okay, and solutions generally have clear appearance, right? And the suspensions may have cloudy and opaque appearance also. Okay, if we talk about visibility of the particles, right, then the particles are not visible with naked eyes in the sol, that is colloid. They are not visible in the solution also, but they are clearly visible in a suspension, okay. Now if we talk about stability, right, then sol are pretty stable, right, colloids are very stable, right, solution are highly stable, but suspensions are not stable, means they are unstable. They will break, their particles will settle down if you leave them for some time. Okay, now if we talk about settling of the particles, then the particles of a colloid can be settled by the help of centrifugation. We have discussed about this method. So you can separate the particles or settle the particles of a colloid by the help of the technique known as centrifugation. But if we talk about solution, then the particles never settle down. If we talk about suspension, for example, mud in water or sand in water, they settle down on their own. Examples of colloids are fog, clouds, milk, blood, smoke, solutions, salt solution, sugar solution. And if we talk about suspension, then the examples are sand in water and dusty air. Okay, now to next question, let's move on to the next question. To make a saturated solution, 36 gram of sodium chloride, that is common salt, is dissolved in 100 gram of water at 293 Kelvin. Find its concentration at this temperature. Okay, so actually what is the question? Let's understand the question. The question is that you are taking 100 gram water in a beaker, and you are dissolving 36 gram of salt, that is NaCl, in it. Now the solution is prepared. They are asking for its concentration. they are asking for its concentration. So you know, dear students, concentration can be expressed in mass by mass percentage, or mass by volume percentage, or volume by volume percentage also, right? So here you see that in both the cases, in both the components, mass is given. You know that the solute, for the solute also mass is given, for the solvent also mass is given. You know that when the solution is prepared, you know that when the solution is prepared, then one component is called solute, which is dissolved, and another component is called solvent, which is used to dissolve, means in which the solute is dissolved, right? So you know that NaCl is the solute and solvent is water, right? For both the mass is given, so we will be using the formula concentration is equal to mass of solute upon mass of solution into 100. So we are actually calculating here mass by mass percentage. Okay, so the concentration will be calculated like this: 36 is the mass of solute, 136 becomes mass of solution, that is both solute plus solvent, right? So 36 upon 136 into 100, total becomes 26.47%. so this will be the mass by mass percentage concentration of the solution. Okay, now let's talk about how will you separate a mixture containing kerosene and petrol. Difference in their boiling points is more than 25 degree centigrade, which are miscible with each other, right? So actually the simple distillation technique can be used to separate the mixture of miscible liquids such as kerosene and petrol, where the difference in boiling point is more than 25 degree centigrade or 25 degree or 25 Kelvin actually. Okay, the which steps we will be following? First of all, we will take the setup like this. Here you can see, and in this setup we will take the mixture of kerosene and petrol. This is the mixture of kerosene and petrol. We will heat it. When we will heat it, here you see that there is a thermometer. So when we will start heating, we will keep a close eye on the reading of the thermometer. Means we will keep taking a record of the temperature also, right? So when we will heat it, you know that kerosene and petrol are the two different liquids, right? However, they are themselves not pure substances, they are mixtures themselves, right? But kerosene and petrol have difference in their boiling points. So actually the boiling point of petrol, if we talk about petrol, the boiling point of petrol is generally 80 to 100 or 90 to 100 degree Celsius, right? However, it varies, right? But if we talk about the boiling point of kerosene, then it falls under or between 150 degree to 180 degree centigrade, right? So petrol has a lower boiling point, kerosene has a very high boiling point. So when you will start heating it, when you will start heating the mixture, first of all the petrol will start getting converted into its vapors. The vapors will move upside and then pass through the condenser. When they will pass through the condenser, they will cool down, right? And because of cooling, the petrol vapors will convert into liquid petrol, which will be collected here in this flask or in this beaker, right? But you know, we have not raised the temperature, right? The kerosene will remain there in the flask only, because we will not raise the temperature up to 150 or more. Okay, now if we talk about name the techniques used to separate the following: butter from curd. Dear students, you can take the screenshots of all the answers, right? You can make your own notes from here. Okay, you can pause them, you can take the screenshots, you can pause the screen. Okay, if we talk about name the techniques used to separate the following: butter from curd, salt from seawater, camphor from salt. What will be the solutions? If we talk about butter from curd, then it is separated by the process of centrifugation. Okay, the principle is that the denser particles are forced to the bottom and the lighter particles stay at the top when they are spun rapidly. Okay, then question B, salt from seawater. So you can separate the salt from seawater by the technique of evaporation. Water being volatile gets evaporated, leaving the salt behind. solid salt behind. Okay, now another camphor from salt. The camphor from salt can be separated by the technique of sublimation, because the camphor will undergo sublimation, right, and the salt will remain left behind. Okay, so sublimation technique can be used for camphor, separation of camphor from salt. What type of mixtures are separated by the technique of crystallization? Okay, so what is crystallization, dear students? The technique of crystallization is used to purify solids from liquid solutions of their impure samples. Suppose that we have an impure sample of crystal of copper sulfate. We have impure sample of copper sulfate. First we will make a very saturated solution of impure copper sulfate at a higher temperature, right? Then we will leave it for cooling. On cooling, the solubility of copper sulfate will go down, and because of this, pure copper sulfate will get separated in the form of crystals. Okay, so what is written here? Once again, let us read it. What is written? The technique of crystallization is used to purify solids from liquid solutions of their impure samples. In this method, a saturated solution of impure solid is made at higher temperatures and then left to cool down. On cooling, pure solid gets separated as crystals because of decrease in its solubility on lowering of the temperature. Okay, now next question, classify the following as physical and chemical changes. So here are some changes given, right, and we will classify them. Students, you know that before classifying something, you should be knowing the concept behind it. You know that pure physical change is that change in which there is no new substance formed, there is no change in chemical properties, right? But if we talk about chemical changes, then a chemical change is that change in which a substance changes into completely different, chemically different substance. So if we talk about cutting of trees, it is just a physical change, because only the shape is getting reduced, size is getting reduced, and shape is changing. So no new substance is being formed, no chemical reaction is taking place. That's why it is a physical change. Now boiling of water to form steam. Obviously when you boil water, right, it converts into steam. That steam is also chemically the water. So there is no new substance formed. Water first was in liquid state, then it converted into vapor state. So this is a physical change. Okay, melting of butter in a pan. So initially the pan, the butter will be in solid state. When you will heat it, it will convert into liquid state. So butter is still butter, right? So no new substance is formed, right? No chemical reaction is taking place, and because of this is a physical change only, because only the physical state of the physical state of butter is getting changed. Okay, now making a fruit salad with raw material. So if you cut some fruits into small pieces, you are just changing the size of the fruits. No new substance is being found. This is why this is a physical change. If we talk about chemical change, then rusting of alumina. In rusting of alumina, the iron is combining with oxygen and making iron oxide. So initially it was iron, but now it is iron oxide. Means new substance has been formed, a chemical reaction has taken place, and because of this is a chemical change. Now if we talk about passing of electric current through water and water breaking down into hydrogen and oxygen. So initially, first of all, it will be water. When you will pass the current, it will convert into hydrogen and oxygen. So initially it was water, then it has converted into oxygen and hydrogen, chemically different substances. So this is a type of chemical reaction. So this is why this is a chemical change. If we talk about burning of paper or wood, you know, when you will burn wood or when you will burn paper, right? The paper, the materials, the organic materials in the paper will react with oxygen and get converted into carbon dioxide and water and some other products. Means the paper's material will convert into chemically different substances, right? So this is a chemical reaction. This is why this is a chemical change. Okay. Dissolving common salt in water. Again, salt is salt and water is water. No new substance will be formed, no chemical reaction will be taking place. So this is a physical change. Now try segregating the things around you as pure substances and mixtures. So dear students, this is the question. In this question, a table is given, right, where we have looked around and we have categorize the things into pure substances and picture. So if we talk about oxygen, then it is a pure substance having only one type of particles, that is oxygen molecules. If we talk about mixtures, then shaving cream is a mixture, iron is a pure substance, air is again is a mixture of oxygen, nitrogen and different types of gases, right? Diamond is a pure form of carbon, while steel is a mixture, it is an alloy, right? Water is pure substance having only water molecules. Soil has many types of substances mixed in it. Copper is a pure substance, paper is a mixture. Dear students, so this was all about the NCERT in text questions. In the next part we will discuss about NCERT exercises. Thank you.